In this example, we will find the general solution of the linear system of differential equations given by y prime equals -5, 2, 1, -4 times y, where y is the vector function xy. We start by finding the eigenvalues lambda 1 and lambda 2 as roots of the characteristic equation, which is given by 0 equals the determinant of our matrix A minus lambda I, which is -5 minus lambda, 2, 1, -4 minus lambda. And when we compute this determinant, we'll get -5 minus lambda times -4 minus lambda minus 2 times 1. And this comes to lambda squared plus 9 lambda plus 18. We can solve this equation by factoring it as lambda plus 3 times lambda plus 6 to find that our eigenvalues are -3 and -6. Now that we have our eigenvalues, we need to find the eigenvectors for each one. Starting with lambda 1 equals -3, its eigenvector will be v1 equals ab for unknown values a and b, and it must satisfy the equation that our matrix times ab is equal to -3 times ab. This comes from our definition of an eigenvalue and eigenvector. Doing our multiplication here, on the right we'll have -3 times ab is -3a, -3b, and on the left we'll need to do matrix multiplication onto the vector, so we'll have -5a plus 2b up top, and 1 times a minus 4b down bottom. We need these two vectors to be equal, so we need -5a plus 2b to be equal to -3a. This gives the relationship between a and b that -5a plus 2b is equal to -3a. And by adding 5a to both sides, we have 2b equals 2a, or a equals b. So we can pick our eigenvector as any vector where a is equal to b. To keep things simple, we'll pick the eigenvector 1, 1. Now for the eigenvalue lambda 2 equals -6, we'll also have an eigenvector v2 made up of two unknown constants a and b. And again, we need to satisfy that our matrix times ab is equal to the eigenvalue -6 times ab. Multiplying out the right, we'll have -6 times ab is -6a, -6b, and doing matrix multiplication on the left gives -5a plus 2b and 1a minus 4b. So again, we need these two vectors to be equal, so the top components must be equal. -5a plus 2b must be equal to -6a. And this gives the relationship between a and b that -5a plus 2b is equal to -6a, which we can solve by adding 5a to both sides to get that 2b equals -a, and thus a can be equal to -2b. Again, we need to pick an eigenvector that satisfies this relationship. So we can take b to be 1, and that will give a to be -2. So we get the eigenvector -2, 1. And this leads us to the general solution that y of t is c1 times e to the -3t times 1, 1 plus c2 times e to the -6t times -2, 1 using our pairs of eigenvalues and eigenvectors.